We're on to hypothesis testing. And in this example, we're going to look at the SAT verbal data again, but in this case, we're going to say that a special group took a prep program. And we'll say it's understood that the national mean score for men on the SAT is a 509. We want to know, does this test prep course work? Does it increase the mean score? So that's what we're going to do. We go out and we take a sample, and we took a sample of these 16 students, and their sample mean was 590. So 590 is certainly bigger than 509. But is it big enough to conclusively say, or to say that the evidence suggests that, that there was a mean increase, that there was an increase in the mean for having taken this test prep course? Of course, to do that, we have to know how wide that distribution is, where we should expect those sample means to come about, and that's what a hypothesis test is. So we are going to see, let's start with step one. As we know, we've got step one of the 6 steps is to identify our null and alternative hypothesis. And I'll always recommend that you write down the claim first. Don't write down the null and alternative right away. Write down the claim first and then the direct opposite of the claim. So the claim here is to test to see if the average score of the test prep group is greater than 509. So that is mu. We're testing to see if mu is actually greater than 509. The direct opposite of that is mu less than or equal to 509. And then remember that the equal sign always goes to the null hypothesis. The equal sign always goes to the null hypothesis. So in step one here, I will have that H naught is mu, and I'm going to go ahead and drop the less than or equal to sign. You can do either way. It's just under the null hypothesis, we're assuming that mu equals 509. And we'll see us do that a whole bunch. So H naught is mu equals 509. The direct opposite of that is our alternative hypothesis, and that is mu greater than 509. So once again, in journals and white papers, you'll see it both ways. Even though it's technically less than or equal to, we're just going to assume that mu equals 509, so that's all you'll see in the null hypothesis. So that's the alternative is there. So now we're going to move on to step 2. And in step 2, we haven't looked at the data yet. In step 2, we're going to set up our test. So we're going to set up our test. This is the distribution from the central limit theorem. It's the distribution of the x bars, right? Because that's what we want the distribution of. We went and took a sample of 16. I want to know if I took a bunch of samples of 16, how much could I expect that x bar to move around? And so we're going to assume, under the null hypothesis, we're assuming that the mean is 509. And we're going to see if what we observed, is that close? Does that agree with the mean being 509? Or does that suggest that the mean should be bigger than 509? So that's what we're setting up here. We're going to say that we have an alpha. If it's not given to us, which I didn't give you an alpha in the problem, then assume it's 0.05. Now, looking at the alternative hypothesis, that's what determines your sides. Is it one-sided or two-sided? And if it's one-sided, is it left or right? This one always points in the direction of which test you have, so this one is clearly a right-tailed test. Intuitively, we're trying to see if the test prep course worked, if the average score actually increased. So that's also why it's a right-tailed test. So I'm going to do what we've done in the past, looking at these normal distributions. We're just going to label this 0.05, and I'm going to do a reverse lookup. But of course, I'm assuming that I don't know the standard deviation, that I have to use the sample. So this will be a t, right? And what we're going to do is say, hey, what is the probability of 0.05 given that, or in our degrees of freedom? So what are our degrees of freedom here? Remember, our degrees of freedom, I'll put right here, are equal to, this is a one sample test. I'm only estimating one mean. So that's a degrees of freedom of 16 minus 1, which equals 15. So this value right here will be a t point, you can look at it either way, I'll write it as 0.05, comma, 15. And if that is the case, then if you look that up in your chart, you should get t of 1.753. So that value right there that separates the bottom 95% from the top 5% is 1.753. Notice we haven't even looked at the data yet. So what we're going to do next is go look at the data. And in the data, we're going to have our t statistic. I'll call this the t statistic. That is equal to x bar minus mu divided by s divided by the square root of n. And we've got everything we need to know to calculate this t-statistic. And that t-statistic will, of course, be our 590 minus 509, which makes total sense. We want to see if 590 is significantly bigger than 509. So we must take its difference and then scale it by how variable we think that distribution is. And we think that distribution has a somewhat big standard deviation, I would think, but then we're going to divide that by the square root of 16. And if you do all that, you will get a test statistic of 2.89. Of 2.89. So clearly you can see that 2.89 is probably way out here somewhere. That's 2.89. And that's meaning that we're in the rejection region. So now we're in the rejection region. We already know what we're going to do, but let's go ahead and find the p-value. If you find the p-value for that test, you're essentially finding this value from here on, which is a subset of alpha. So you can see that this is smaller than 0.05, which is what alpha is. And given software, you'll be able to find the p-value equal to 0.0056. 0.0056, which of course is less than 0.05, which is alpha. So my second to last step is to reject HO, right? Because 590 looks to be way bigger than what we would expect if the true mean was 509. I'll say that one more time. If the true mean is 509, when I pull samples of size 16, I don't expect to see something as big as 590. It could happen, it's just not likely. How unlikely is it? It would only happen, if I did this test 10,000 times, it'd only happen 56 times out of that. We'd get something that extreme or more. So it's very rare that we would see 590 or more given that it's 509. So we're going to reject the statement that it's 509. And we're going to conclude here in step 6 that the evidence suggests, we don't know anything, we didn't prove anything, we're just saying what this particular sample of size 16 suggests. The evidence suggests that the mean score on this test, on the SAT verbal test is greater than 509. That's what the evidence suggests. And then I always add, and you should always add the p-value to give whoever's reading this how certain you are that that is true. And then you could put down here something extra that says the evidence suggests that the PrEP program worked. The evidence suggests that the PrEP program worked. It looks like the true mean actually increased. And that is an example of your 6-step hypothesis test. Great work. Awesome job. Keep with it. See you next time.